off our 6-part series, a night course for the end of the world. We're delighted to have Mary Burke, Earth and planetary geomorphologist, there we go, with experience in extreme climates with us this evening, looking at hurricanes, floods, wildfires, earthquakes, our changing climate and the doomsday scenario that might be the end of us. How the plan so far has worked is it's about a 40-minute talk, and we do encourage people who have any questions along the way, you can tweet them at us on our Twitter page, or you can head onto Facebook and comment underneath the live stream video, and we'll ask out the questions at the very end. Do put the 10th of January in the diary for those who are going to all 6 of the series, because we'll be doing a bit of ceremony at the end. And I'd like to just give Mary a round of applause and we'll get kicked off. Thanks.
Hi everyone, very big welcome to come to these series of talks, which I've seen the first of and find incredibly interesting. Everybody should have one of these. We'll use them later, so you can put them aside for now. We'll get on with talking about climate catastrophe. So this idea, this interest that we have around kind of catastrophic and extreme events is something that has certainly gripped me during my career since Hurricane Charlie, in fact, where I did my research on that way back in the day. I'm seeing my slides here. Would you like me to?
Yeah, start there. Yeah.
Well, it's launched already on my computer.
Okay, you may need to relaunch it again.
I shall do it. Awesome. Fantastic, thank you. So, climate catastrophe, the end of the world. Apparently it's near. We know a lot about this. It's happening. In fact, I can tell you when it's happening. It's happening on the 29th of July 2016. Whoops, that's last year. Hang on, whoa. It didn't happen. Okay, next one. 13th of May 2017. No, that's already gone. Bummer. Okay, the end is near. It's very near. Very, very, very near. It's happening. It's going to happen anytime soon. Apparently, the latest one is November 19th. Has anybody heard about this? Yeah. This planet, this fictional planet, Nibiru, I can't even pronounce it, is going to pass in its orbit in the Libra constellation and cause this huge shift of energy on our planet, and the entire planet will be devastated by earthquakes on November 19th. So, these things happen all the time, and they give us a bit of fun and a lot of annoyance at times if you're a scientist and you're constantly fending off phone calls, etc. But what's interesting about this is that there is natural events that feed these catastrophic ideas about the end of the Earth. If we look here at this table on the bottom left here, you will see that there have been 129 earthquakes in the last 24 hours. So there's a very big chance that there will be earthquakes on November 19th, and it will feed into these end-of-world prophecies. In fact, today we've had 3 significant earthquakes above 4 on the magnitude scale out there, occurring where they should occur, which is on plate margins, where the shifting of Earth's plates cause tension to build up, and the release of that tension causes earthquakes to happen. It's a geohazard, not a climatic hazard, but this end-of-the-world kind of catastrophism is not something perhaps that as scientists we pay an awful lot of attention to. But some very, very eminent scientists have talked about this existential threat to humanity and have identified 4 potential existential threats. The climatic one, the asteroid impact one, the social one, perhaps nuclear war, and of course biological. And so I've been invited today to talk to you about the climate catastrophe. And perhaps in terms of the end of the world scenario, I'd like to redefine it as being the end of the world perhaps as we know it, rather than the end of our planet and our species. Although we will come back to this. And certainly in recent times in Ireland, we have been visited upon by some strange and unusual climatic events. If we think about in August, Donegal, County Donegal, one of the most beautiful places on our planet, apparently, according to Lonely Planet, was devastated. The local people were devastated by an extreme event that caused landslides, local floods, and massive infrastructure damage on that particular small part of our island. And then, of course, we've all just lived through a hurricane. I mean, it was downgraded from being classified as a hurricane because it lost its eye. But the scale of the winds were hurricane-scale winds that we had to endure here in Ireland. And, of course, different parts of Ireland had different magnitudes of effect. And it was a very, very unique event. Instead of drifting across the Atlantic, it kept its trajectory straight up towards us in Ireland. Now, of course, it was the first time that the entire country had been given this red alert. And as we all know, in the media afterwards, there was lots of discussion about who did what on time and how effective it was. But we were definitely told to keep our children at home, to keep them safe from the winds. Some of us have different measures of success on this particular effect. And of course, the Irish had a fantastic sense of humour about it. Jesus, sure, if he is coming, what in God's name is going to happen to us all? Are we going to shift north? And we put out these warnings to friends and to family. I don't know any of these people. That's my godson, Oisin. I called them and I said, pin down the cattle. The winds are coming, but sure, they had enormous fun. But of course, this is not our first time to experience a hurricane, and I'm doing that because we're not allowed to call Ophelia a hurricane because it was a lower grade storm, a tropical storm with hurricane scale winds. Hurricane Debbie hit us in 1961, causing immense devastation. Storm Ophelia, we had winds of 191 kilometres an hour, were the highest clocked winds to hit our nation. But if we go back even further in time, I don't know if many of you have heard about the night of the big wind in 1839. This is where people had just got through Christmas. It was Women's Christmas, and people were basically in their homes, knuckling down, building snowmen, etc. in the yard and coming in for their tea, etc. And the wind was building during the day. And they had no mobile phones, they had no forewarning. They were sitting in their homes, and they heard a howling wind build and build and build. Apparently the winds were so strong that people were pinning down their children. We may laugh at my nephews in that video, but that night in 1839, they were securing them in boxes and putting wood over them and stones over them. They couldn't stand in the winds. They had to crawl on hands and knees, and they couldn't speak to each other unless they were grasping each other and shouting into each other's ears. The death toll was about 300 people. Roofs were blown off houses. Most people, lots of devastation in Dublin. Most people were injured from falling chimney stacks. People didn't know how to manage that kind of a hazard because they had no notice and absolutely no experience. The cliffs of Moher were the highest cliffs in Western Europe. The waves were breaking over the cliffs of Moher. It was absolutely a phenomenal big storm and a hurricane, definitely at that scale. So Ireland is not a stranger if you think of the longer records to these extreme events. And then, of course, you look at other big events that have happened recently, phenomenal ones, that we seem to be in this constant stage of breaking records, and new records are happening. Here's the Houston floods from Hurricane Harvey. They had over a metre of rain in 4 days. An enormous amount of water fell in that very flat coastal plain where they had massive urban expansion in the way of the natural floodplain. Over 90 people dead, I think it's actually 91, and 450,000 people required assistance from the federal agency. We've all heard about this. It caught huge media attention. How many people heard about this? Same time, same planet, same hazard. very little media attention, and much more devastation. Mumbai floods. Over 1,200 people dead and 40 million affected. 40 million people on our planet affected. And that blue area there on that diagram is the area that was inundated and flooded due to these massive rains. Transnational, single climatic systems that go across national boundaries. And so with all of this recent activity, we are asking ourselves, well, what is actually going on our planet? Like, are things changing dramatically, and do we need to sit up and take notice? For the next little while, what we're going to do is go through what might be going on. Is it real? Or is our perception of it real? Okay? So do we have a heightened perception to risk? Or is there actually an increase in risk? Well, there's a couple of factors that are building into what we know about risk. And one of them is the fact that we're now collecting data on it. We're collecting data now every time there's an extreme event or a disaster happening on our planet. And so in 1964, the Office of Federal Disasters was set up, and another one here, CRED, was set up, a European one, to start recording both natural disasters and the outbreak of disease. And you can see here a rise in the number of reported events as we move through time. So it is definitely true that there are institutional reasons as to why we think there's more natural hazards happening right now. They're just being reported. But then it's also the media attention. So going back to the Donegal floods, I went down to my local centre the next day, I saw the newsstand, and I took these photographs. The Irish Independent, counting the cost of a once-in-a-century storm. Annoying. It's not a once-in-a-century storm. It has a probability of 1 in 100 years, which means that in any given year, it has a 1% chance of happening. It is not a 1-in-a-century storm. It's one of our bugbears as scientists. You might have got that message. The Irish Times. Thunderstorms leave a trail of destruction across the northwest, and there's the tractor in the hole in the middle of the road. The Irish Examiner. I love the Irish Examiner. They've just got sound scientists working and reporting on climate and all sorts of environmental issues in the Irish Examiner. The Inconvenient Truth, and we all understand what that's a play on. This is the shape of things to come. So perhaps an echo there of like, what's going on here? Let's sit back and look at this. And then, of course, we have the Star, carnage. And I kind of looked at all this and I felt a little bit, I must admit to having like a psychological reaction to this and an emotional one, like, Jesus, what's going on here? So I feel that as a human observing the media portrayal of events, that I am being subject to a conditioning in a way of feeling like I am more at risk personally and my country and planet is more at risk. And it's not only the broadsheets or the established newspapers, it's also this idea of embedded journalism, both professional and non. We now have people tweeting from the disasters as they're actually happening. We're looking at tsunami waves, earthquakes happening here, and these are the pictures that are being sent right before the tsunami's coming in and affecting, most likely devastatingly, here. We're looking at survival here of people, their homes destroyed, their places of worship destroyed. So they have an enormous effect on us, especially if you are on social media. And social media itself is playing a very important role, both in alerting people to disasters as they're happening. For example, in Japan, you can have a Twitter account, and the minute there is a seismic event detected, you will get notification on that Twitter account, and you can take action because of the associated or linked risks to that. So there's lots of reasons why we might be having feelings around it. But what does the science say? So what we would call geophysical hazards, the earthquakes, the volcanoes, they're not increasing. They occur randomly in time, but not necessarily in space. So if you think that there's more earthquakes happening, there may be a bunch of them at a certain period of time, but over time, over a century scale, there will not be an increase in the frequency of earthquakes. Climatic hazards are a little bit different. These tend to vary, and we know, of course, that they're linked, these climatic hazards are linked with increasing atmospheric temperatures, increasing ocean temperatures. And the science is starting to come in. So what we're looking at here is basically a record that is showing that between 1950 and 2010, these what we call the CHMs, the climatological, the hydrological and the meteorological events. And these events are responsible for the most deaths on our planet, these particular hazards. More than tectonic ones, more than volcanic ones. And what the data is indicating to us is we've seen a threefold increase, with interannual variability, of course, but a threefold increase in that period of time. And then this year, scientists got together to review a range of instrumented data from across Europe, including a very excellent team from NUI Maynooth, the Icarus climatologists there. And they pulled all of Ireland's data along with the data from the rest of Europe, and they were able to make a conclusion. They weren't looking at the magnitude of events, have the biggest events increase over time. They were looking at when they're happening. Is when the big flood's happening, is that shifting? And they said yes. They have found now, by analysis of those massive data sets, that there is a clear climate signal in flood observations at the continental scale. And so there's 4 different kind of categories, depending on where you are in Europe, of what that change actually is. So, for example, if you're here in this area, zone 1, it means that you're subjected to earlier snow melt. If you're in zone 2, you're subjected to your winter storms happening much later in the year. Here in zone 3, you're getting earlier soil moisture maximum, and this is where Ireland is jutting into. Your soils are getting wetter earlier in the year, and if your soils are wetter, when it does rain again, there's nowhere for that rainfall to infiltrate into the ground, so it will run off. And so you will have a higher incidence of flooding earlier on. And down here, it's a stronger Atlantic influence in the winter in terms of storms. What does that mean? We think of our farmers, we think of our agricultural land. There's going to be, again quoting from this paper, considerable economic and environmental consequence because we're used to a different kind of weather and climate. Everybody's talking about how things are budding and flowering now in November, and they shouldn't be. The gardeners, the people we love to go visit to look at their gardens, are wondering what is going on. For us in Ireland, September, October literally mean middle of the harvest and end of the harvest. And we're in that zone that's looking at that shifting of flooding earlier on into September and October because our soils are wetter, they're getting wetter earlier. So the agricultural industry in Ireland is in for some trouble. And this is not model data, this is analysis of real data. So the science is saying that. But we are talking about hazards. And a hazard is not just a hurricane. A hazard is when that hurricane interacts with human beings. Physically, the people, their property, their amenities, that's what we define a hazard as. And what you're looking at here is an exponential increase in human population with time. And we're expanding our footprint on this planet. And so we have a higher likelihood of intersecting with hazards as they occur naturally. So hazards are going up potentially because human population is rising. Today, our population, and I mean today, is 7.57 billion people. And it's projected to rise to 11.2 by 2100. Geography, as a geographer, is also important. Where you live on this planet will also influence what kind of hazards you are subjected to, and therefore whether or not you're at higher or lower risk. So here you're looking at a map of global hazards. The different colours represent different features. For example, you can see that the earthquake hazards are shown all along these plate margins. So everywhere there's a plate margin, you have a higher likelihood of tectonic activity and seismic shaking happening. The green are these tropical windstorms, and you can see that they're located in the tropics. Volcanoes are these black dots dotted around. But what's worrying about this is that these areas, and remember these are one of these CHM hazards, the ones that cause the highest deaths on our planet, they're associated with the highest rate of increase of population. So that 11 billion increase to 11 billion is going to happen predominantly in these areas here that are also subject to this highly destructive natural hazard. So looking again at this kind of data, what we're seeing is that with the reporting of the hazards, the number of people that are being impacted by them are also increasing. So the people being impacted by it. You're being removed out of your house is being flooded, your forests are going on fire. But the good news is that the number of people dying is decreasing. And that's because we are taking measures to educate people and warn them of these impending hazards. Now this next slide is full of numbers, but it's an important message. And if we look at the disasters and we look at where they've happened, the point I want to take home here is that you've got the deadliest ones and the costliest ones. And the deadliest ones in terms of hundreds of thousands of people, Haiti, Indian Ocean, Myanmar, Pakistan and China. The costliest ones, USA, Japan, China. So there's a message here. Depending on where you live on the planet, you may be more likely to die as opposed to have to fork out higher insurance premiums. If we take an example of Japan and Haiti, both suffered from an earthquake. Okay, so 20,000 deaths from the earthquake in Japan. Haiti was 100 times lower in magnitude, but look at the number of people who died, over 300,000 people. And a lot of them don't die directly from the actual hazard itself, but from the subsequent events that happened, the lack of infrastructure and support, the spread of disease. And so we have this matrix when we think about where we need to invest as a planet in terms of improving resiliency and management of hazards. And so you're talking about vulnerability and your physical exposure. And so you've got these high risks but high security, meaning Japan has technologies that can assist. They have tsunamis, so they build these high walls. Haiti happens to also be a high risk, but it has low security, which explains why there's such devastation every time there's a natural hazard. But before we get too complacent, high security societies can also have high vulnerability, and it's not for the reason you think. So this is an image from Taiwan. There was a 2016 earthquake here, and these are apartments that house 250 families that basically collapsed during an earthquake. And you think, okay, well, you know, buildings collapse during earthquakes. All the buildings around it didn't collapse. And when they went in to actively rescue the families, the children that were still, the earthquake happened at 3 o'clock in the morning, they found this. The stability of the structure had been packed, instead of rebar and cement, with empty cooking oil cans. So high security is subjected to corruption. And so we're not all safe, despite what we might like to think. So, climate. I've been invited to talk to you about climate catastrophe. And catastrophe, I mean, what does it mean? It means that basically something terrible happens, but we have an ability within society to recover somewhat. But just recently, papers are now being published by highly esteemed climatologists, scientists, that are actually suggesting that within our children's lifetime, we, our planet, may be subjected to an existential catastrophe where our species might be wiped out. And this is the first utterings that I have heard from scientists on this matter. And so we'll watch this space and we'll see why people are thinking this and if this is true. Because if this is true, then we need to start thinking about, well, what can we do about that? I mean, are we looking at the human species being wiped out by climate catastrophes in the next very short while? So, as well as working on extreme events here in Ireland and elsewhere in the world, I've also spent a little bit of time working on the planet Mars. And so I have an interest in thinking about the colonisation of the planet and looking at other options about where we might go as a human species. And so the first point I'd make is that we're already space travellers as humans. We have the International Space Station. It's done an enormous number of flights since 1998. We have people who have been trained. We have technologies that are developing to assist us in this ideal of perhaps going beyond our own planet out into our solar system. And one of the planets that's come up quite a lot is Mars. And we have sent a lot of missions to Mars. We have sent, well, we've tried to send 44 missions to Mars as a global community. But it's very, very hard for them to be successful. So you're looking here at a scorecard. Mars is 123 and Earth is 121. What that means is 23 missions have crashed and burned before even liftoff, and certainly upon orbiting and trying to inject into the orbit and land on the planet. But at the moment, we have a huge number of missions that are going around that planet collecting data for us. And I worked on lots of these mission data sets while I was in the United States. We have 6 satellites that are orbiting the planet right now, collecting surface data and atmospheric data. And we have 2 robotic geologists that are roving. They're not just landers, they're actually roving around the surface of the planet and collecting data for us. And so what do we know about Mars? Well, early on in Mars exploration, the most recent phase, we sent up a laser altimeter to the planet Mars, and it sent back a topographic map of Mars. We had accurate topographic data from the planet Mars at this scale before we had it for our own planet. It's an interesting planet. You can see here a huge canyon that is actually the size of the United States of America. Massive, tall volcanoes, the tallest volcano in our solar system here, Olympus Mons. A very topographically varied planet. So it's valleys, canyons, mountains, etc. But if we're going to go to the planet Mars, we need to think about surviving there. What? Is there water on Mars? Yep. Loads, actually. Quite a significant amount of water on Mars. So this is one of the instruments we sent up most recently. It had a gamma ray spectrometer on it. It basically was able to detect hydrogen at the surface and in the soil. And there was quite a significant amount of water at the surface and just beneath the soil at about 30 to 1 meters depth. That is H2O. That is potable water that we could, if we could get access to it, we could use it for fuel, for survival. Again, another visualization of Mars. But what I want to show you is that at the south and the north pole of Mars, there are 2 large ice caps. And while seasonally they might have carbon dioxide ice on them, in their perennial state, they are water ice. At the south, and now we're rolling up through the pockmarked, impacted crust area of Mars into the smoother northern plains, and here we're at the northern ice cap on Mars. So, you may not know this. The only known planet inhabited solely by robots. Mars. We've sent a lot of infrastructure, robotic infrastructure there already to collect data, and this is basically the family of robots that we've sent to Mars over time. So when I started out, 1997, Sojourner the size of a suitcase, it basically went over, put out its spectrometer, collected the data and rolled back, and it just went basically to rocks. And as we've moved through, we set out a set of twins here in 2004, and at the moment, of course, it's Curiosity, this wonderful geological and chemistry lab that is actively collecting data for us. And so that rover landed here. It was given, like all NASA missions, it's given a certain amount of time to do its work, 90 days. 90 days, collect your data, and if you're doing a good job, we'll think about extending you a little bit. Massive success. The longest distance that any rover has ever travelled on any planet in our solar system. It's now 11 years and it's travelled 45 kilometres. And this is where it is at the last report, October 17th. This is its track here. It's sitting here on the edge of a crater, taking data as we speak. And so from all of this data, what have we learned? Well, we knew before we even went that it was predominantly a carbon dioxide atmosphere. So that's not great, because we can't breathe that. That's unfortunate. But there is, different other species of molecules in there that perhaps we can use. It's a very thin atmosphere. It lost its atmosphere very early on in its history. Mars had a catastrophic, an existential climatic crisis early on in its history, where it lost its magnetic field, and basically the atmosphere has been eroded away as a result since then. We do have wind on Mars. It does blow gusts, winds of 16 to 35 kilometres an hour, but because the atmosphere is so thin, you don't really feel it. It might fluff your hair a little bit, but it's certainly not like anything we felt standing out there in Ophelia. It's twice as long, the year is twice as long on Mars. The days, the rotation of the planet is similar to Earth, so the length of the day would be good for human colonisation. It's cold, it's so far away, it's about 1.5 times the distance from the sun that our planet is. It's just on the edge of that so-called Goldilocks zone. Yes?
Are there seasons?
Yes, there are seasons, just like Earth. It has tilt to it, and as it processes around the sun, we get spring, summer, winter, and autumn on Mars. Now, who wants to use their funky glasses? So we're going to indulge ourselves now by just having a look at some pictures that have been taken from the surface of Mars. So the first thing you need to do is make sure that the blue lens is on your left. Okay. So what you're looking at here is an image that was taken by the rover. If anybody needs a pair of glasses, just stick up your hand. So you should be able to see this in 3D. So this is what it's like actually being. This is an image taken from the surface of the planet Mars. And this is an image taken by the rover looking across the edge of a crater into the vast distance. And what you can see in the near distance are these rocks that have these markings on them that is abrasion by sand grains. So I said there was wind, and there's quite a bit of sand on the planet, and they abrade and corrode the rocks over long time periods. But if we were to send humans to Mars, of course, this would be a hazard that the people, the new inhabitants, would have to endure. It's got two moons. This is an image of one of the moons. This is Phobos. And you can see it's pockmarked. There's lots of evidence of collision with other objects in the solar system during the lifespan of Phobos. And that collision is very important for Mars. It's how mountains are built on Mars. It was an exam question I asked my students today. I don't think they liked it. How are mountains built on Mars? So what you're seeing here is an impact crater, its rim. You can see some evidence of ejecta that's been exploded out of it. A central pit here that sometimes happens if we've had impacts into icy terrains. And of course, there is lots of evidence that Mars has had a very watery past. These are channels that were carved, we believe, by catastrophic floods that burst out of the crust of Mars early on in its history. And these are teardrop-shaped islands, and some of the floods have gone down into these caverns and gone underground. But it's still a bit hazardous. This one is not in an anaglyph form. This is an image that was taken by one of the satellites of a spot it had visited before, and it came back a few years later and noticed that this was a new feature on Mars. Because the Mars atmosphere is so thin, meteors coming in through the atmosphere like they do on our planet, we see them as these so-called shooting stars. They're not shooting stars. They are dust and rocks coming in from our solar system and burning up in our atmosphere. Because Mars's atmosphere is thinner, smaller objects will actually reach the surface. So if you have a habitat on Mars, and you know that we have evidence now of impact cratering going on today on Mars, this becomes a pretty serious hindrance to development of habitats on that planet. Here is evidence of a very watery past. We're looking here at a meander bend like you'd see in any of the rivers in Ireland. It's inverted because it's very ancient and it's been exposed. Here is some of the typical landscapes on an afternoon if you were living on Mars that you might like to go out and fly around, because of course the gravity on Mars is significantly less than that on Earth. So basically if you want to run and jump off something with a very small propulsion system, you could actually travel a really great distance. And you're seeing here some beautiful hills with some dark basaltic sand dunes, and here is another crater, or not crater, but a canyon that's been wind blasted and etched out on the surface of Mars. So what do you think so far? Interested in going to Mars? I'm seeing lots of rocks. Canyons, again etched by the wind. Are you getting the impression that the wind might be a bit of a problem? Beautiful, deep craters. Lots of holes on Mars, and some of them are collapsed terrain. Remember I mentioned before that the floodwaters might have gone underground in these cavernous systems? Well, this is other evidence for cavernous systems underground, basically just collapse of the overlying terrain and big escarpments. And finally, it is such an ancient crust that lots of people see these images and think it's evidence of an extraterrestrial life form. And it may be that there is life on Mars. Certainly the conditions that would lead to life on Mars have been set up early on. We have dunes on Mars that are absolutely beautiful Barkhan dunes. They are significantly larger than the dunes that we have here on Earth. We have sand drifts and rocks. And we have a very dynamic surface where these are images taken by one of the rovers of these dust devils moving across at enormous speeds. And these aren't all hazardous. One of these dust devils actually went and impacted positively on the actual rover itself. The rover was being powered by solar panels. And on Mars you have a ubiquitous falling of dust all the time. And these solar panels from time to time really get covered in dust, and their ability to power themselves is reduced significantly. And one day the scientists went and looked at their battery readings on Mars and suddenly saw a big spike in power. And when they pointed the cameras down on the solar panels, they saw that they had been miraculously cleaned. And they believe it was one of these, came along like a hoover and just sucked the dust off the panels on Mars. So we have an atmosphere on Mars. These are water clouds. We also have carbon dioxide, snow and frost. And there is tantalizing evidence that there is liquid water available at the surface of Mars. And what you're looking at here is a time series of images that was taken. And these should be envisaged as being basically wet, soggy soil, which I think we can get a grip on living in Ireland. But it's like very slowly seeping down a slope on a sunny, warmer slope on Mars. And of course, under the current temperatures and pressures, water shouldn't be stable on Mars. Basically, it should bubble and boil away immediately the minute it reaches the surface. But if it has salt in it, and there is a lot of salt in the soils on Mars, it depresses the freezing point. Some of the salts, for example, one that's called perchlorate, can depress the freezing point of water to minus 70 degrees. So you can have flowing water in a liquid phase that would taste awful, but it is liquid water on the surface of Mars in some areas. And then you have these unique and bizarre phenomena that we don't get here on Earth. And of course, ice, there is water ice, but there's more carbon dioxide ice that freezes out seasonally during the winter on Mars. Whoops. These two doggies are known as Dalmatians. And this is a name that we gave to a phenomenon that we discovered on Mars. This was an image that came back. And we called them Dalmatian dunes, because we had no idea what they were. These were seasonally occurring dark spots on icy covered sand dunes. And with time and with investigation, we discovered that it was geysers of sand and CO2 gas exploding from underneath that seasonal ice cap on the surface of Mars. Wonderful, perhaps, to observe. They can go over 100 metres high at velocities of 10 to 20 metres per second. Potentially a source of power on Mars, perhaps, but also an incredible hazard. So, we're talking about sending humans to Mars. Sarcastic Rover is a great Twitter account you might like to follow. How to recreate Mars on Earth. Lock yourself in a freezer, make your eyes boil, and hold your breath until you're dead. So, it's definitely problematic. What we need to think about is how we can develop technologies to the point that we're going to be able to send people there safely. And I haven't seen anything yet that gives us the technology or the instruments or the fuel source to be able to get humans there and get them back off the planet in a safe way. But we did have these guys who are biological twins, and we kept one on Earth and we sent one into space for nearly a year, and we're analysing all of the data that was collected from these two very courageous people who took part in it. And one of the things we're finding out is that we will get older faster by going into space because of these telomeres shrink with exposure out in space. And of course, everybody has heard about the radiation risk, but the argument isn't actually proven. So here is Mars round trip, unshielded, so don't worry about any radiation dose of what you might get. And yet we've had astronauts on space stations for much longer periods of time and showing no ill effects of radiation. So let's wait and see about that. I don't believe that that's actually what's going to happen, but there are several challenges to overcome in terms of thinking about settling on another planet. And radiation protection is definitely one of them. But human psychology is also another of them. And that is why we're undertaking all of these experiments in different desert areas on Earth to try and figure out how to get people to get along with each other for extended periods of time. And then they'll publish a book on it and called Men Are From Titan and Women Are From Somewhere Else. But we're learning a few important things. We're learning about conflict resolution. So the Mars 500 was a bunch of, I believe it was Russian men who were sequestered away for a very long, 500 days is a very long period of time. And there was all sorts of issues coming up, of course. And they figured out accidentally that one way to get the team to pull together rather than fight each other was to create an external problem that people back at Central Base were responsible for, people back on Earth were responsible for. So everybody basically, like any office environment, gives out about the boss, comes together as a team and does more productive work in that way. So these are interesting little kind of nuggets that all of this investigation and investment of money is helping. But there's no doubt that there is a great interest in Mars as a destination. I'm not clear on how realistic that is. I'm not clear that that is the right place for us to be going to. But I do know that now that we've got commercial entities involved, that the race might be on to do that. No government is going to do it alone. The amount of money is required. No single nation and no government agency. You're going to have to be a global collaboration to do this. And if we think back to what can happen when you put your mind to something, this is the US, basically the timeline of where we got to. It took us 12 years from Sputnik, human goes into space, human lands on the moon. 12 years. Like phenomenal rate of progress. So I have no doubt that we'll get there, and we'll get there rather quickly once we get invested. However, when people back in this day, this golden age of space travel, they thought we'd be on all these other planets by the 70s. So they were deciding, okay, where is the best place that we should go next? We've gone to the moon, where will we go next? And they decided, here. Don't go to and don't land on any asteroid or planet, because there's so much we don't know. Growing humans and no gravity, we have no idea what kind of potentially disabling effects that could have on our species. But it can be easily fixed if you have this basically platform that spins at 1.3 revolutions per minute, you create Earth's gravity. And so maybe it's a case that if we do go and land on an asteroid or Mars and try and colonize a planet, that we have a nursery suspended above us where the babies are born and the babies grow and then they come down where they're adults. Who knows what the future might be? But all I can say is, as I close out this lecture, is that it's not actually a choice for our generation. This is all way in the future, and we will not travel to space. And so it is incumbent upon us to do the best that we can with the lot that we have. And what I would suggest is that we all take this very, very seriously, that whether or not it is an existential threat, or whether or not it just becomes a series of catastrophic storms that hits our island and other places on our planet, we need to step up and take notice, because I have no doubt that things are changing. Thank you.
I think, as Mary said, the world might not end totally, but maybe as we know it. I think I definitely have more questions than answers after that, but really fascinating lecture and doomsday predictions. Does anyone have any questions to kick it off?
How many people want to go to Mars after that? I'm going to put my hand down now because I don't want to go. I've been on flights to Australia. You can keep it. It's wild. Yep.
Hi. I actually already have my name in Mars, so it's fine. You were saying that we can't talk about Ophelia as a hurricane because she lost her eye, as you said. What does it actually mean to lose an eye?
To what?
To lose an eye off the...
Oh, sorry. So you know that if you can visualise now those lovely satellite images of swirling white clouds that in the very centre have a hole or an eye. So basically the system just broke down physically because you didn't have the temperatures, because it started moving over colder water. So it lost that vortex system that kept it powered, and so it lost that kind of integrity of a hurricane, and so it just became a system without an eye that had a very strong wind force with it.
And was it because the waters weren't as warm as they were before?
So it's a really interesting question. It was a perfect storm in many ways. I haven't read any scientific publications on it at the moment, but the people that I've spoken to have basically said there was the temperatures in that part of the ocean were warmer further north for this time of year than they should have been. Normally the storms are tracked across following the thermal gradient, but also captured by the jet stream. Now, at that weekend in Ireland, the jet stream was doing this. And so basically the northern moving part of the jet stream almost like caught it and helped it maneuver in a northern trajectory rather than going across the Atlantic as usual. So it was that kind of coincidence, if you like, of atmospheric and oceanic systems that led to it coming across Ireland.
Hi, thanks. You mentioned the 4 existential threats to humanity at the beginning of the presentation. Is there any scientific evidence, or even in your own opinion, is one more likely than the other to cause...
Donald Trump, what? Sorry? Wasn't that existential threat number 3? That's more than... I think they're all more likely. I think the climate one is less likely. I think the nuclear one is real, but whether or not it will completely wipe out our species or 90% of humans depends on the scale of it. Biological, I think, is, I think we've had pandemics before, the Spanish flu. There was something like 8 million, I believe, 6 to 8 million people that died as a result of that. The Ebola virus was contained, but, with the connections in between, our global connections now, it's so difficult to keep control of some of these species, and we don't have the right vaccines in place in the right quantities to take care of it quickly. So I'm not going to tell you what you're going to die of, but it may not be one of those.
I
I think one thing that was mentioned last week was maybe it's a accumulation of a number of things. So you have, economic disaster, you have climate catastrophe, and then infectious diseases. So I know it's
I
not
agree
very
completely.
heartening.
Yeah, nothing is happening in isolation at all. And they're all interlinked, of course.
Yeah.
With a warming climate, we're having all of these changes predicted for insect species. Wasn't there something in the news recently about how the number of insects are reducing dramatically in this country and across Europe? So they're all interlinked and intertwined.
We had a question from Twitter from Lucy. Besides Mars, is there another planet that we could consider possibly living on?
Yeah, I think so. I mean, they're all very challenging. Titan is a moon, and it's. I think it has potential because it's the only other body. I mean, called things that are not planets, moons, and stuff bodies. It's the only other body in our solar system that has liquid on it. It has rivers. It has sand dunes. It has lakes that fill up and drain seasonally. It has weather systems that rain down methane. Okay? Stinky. So I think, so what I'm thinking there is in terms of generating power. You've got fluids that are mobilized, you've got wind and a liquid that's moving, you've got a dynamic system, and there is potential perhaps to think about that. There's asteroids, whether we go and live there, certainly in terms of mining them, that seems to be something that's growing now in people's interests, to try and mine them for rare metals that we need here on Earth. But perhaps the small colonies will be built there, and in this kind of like hopping across our solar system. You go to an asteroid and you move with that asteroid as it orbits, and you get your fuel and your resources there, and then you move on. Asteroid hopping, I don't know if it's a thing, but I think I've just coined that. But they're the ideas that people are having around. So what is the idea of colonization? Do we have to go somewhere and stay there until we all die? Or is it something like that we just use our solar system as a stepping stone out towards all of these other exoplanets that we're discovering? And some of them may be in this ideal Goldilocks zone where it's not too hot, not too cold, but just right for the survival of our species.
Hi.
Hi.
You mentioned that Mars is the only planet whose residents are the robots.
Yes.
And now they are busy in getting all the data.
Yes.
But you also mentioned that the landscape is changing very dramatically on Mars. So, and like in the past of the time, the robot doesn't cover that big area of Mars. And do you think because it's changing so dramatically, and maybe like one day cover this part, it has been changed completely, and the data does not mean that much, and do you think that would be a problem?
Okay, good question. It gives me an opportunity perhaps to fine-tune something that I said. The message would be that it's a very dynamic planet, that the winds blow sand around, that every season you get an ice deposit. But it's not changing the surface of the planet that dramatically. Probably dust is in terms of the albedo or the reflectance of the planet, but the larger structures, the bedrock, the mountains, the canyons, they're not changing. There might be some sediment moving down them, but it's very gradual at this point. The rates of erosion on Mars were much, much higher back in its history, back much further than 3.5 billion years ago, when it probably had an atmosphere and it had rivers flowing and it had large bodies of water and active volcanoes. But at the moment it's dynamic, and there are hazards for humans, and they need to be careful about where they set up. But the data we're collecting, I think, has an integrity that will last beyond when we actually have the technologies to go and arrive on that planet.
Thank you.
We have one more question? Yep. Two? Okay.
Hi.
Hi.
Do you believe, climate-wise, that we have reached a tipping point?
I think See, tipping point is a very specific term, isn't it? It's a term beyond which there is very great difficulty in returning back to pre-existing conditions. So I would say that we're moving towards it. I don't think we've hit tipping points in terms of other, nitrogen and stuff in our atmosphere, but I think in terms of our climate, it looks like we're trending towards a change. And it unfortunately may happen sooner rather than later. Yeah.
Thank you very much.
Hey, hi. I have a question to you about the twin study that you showed.
The twin study, yep.
Yeah. So you mentioned that it was found that some of the data that we might age faster while in space, right?
Yeah.
Why NASA website does not agree with you? And they actually say...
I don't know why NASA's website doesn't agree with me.
Yeah, because it says that actually...
I didn't know that they didn't agree with me.
Yeah, it says that actually on NASA website, I found it, that actually for a person who was in space, the telemeters actually increased in length, which potentially means, well, can you just explain this, or maybe just understood something incorrectly?
So I don't know where your source is, but my understanding is that there is an aging process that happens within space. But I would
it is faster than on Earth.
Yeah, but I would have to say that it's potentially not the worst thing that is happening. I would be more concerned about human strength and flexibility in space. So, for example, one of the Kelly twins who was in space had to, and all the astronauts have to do constant, hard, weight-bearing physical exercises every day to try and maintain their structural bone strength and their muscle strength. And you've seen many, many images of astronauts coming back in from space travel where they physically are not capable of walking once they get back into Earth's gravity. So there are other things. There is evidence to suggest that perhaps cataracts might be, so blindness might be accelerated in space. There's quite a suite of other health hazards. I don't think the aging thing is that significant. But I do wonder. I had up a table where we looked at how the human lifespan has increased from 18 years to 78 now in the United States. It's 81 and a half in Ireland. God bless you, God bless you. And I just wonder whether our lifespan will decrease when we go into space from all of these reasons. You know, that we're looking at sending out a generation that will die at 30 or 40 or 50 because of these hazards if they're not adequately dealt with. Mm-hmm. Yeah.
Okay, thank you.
One last question that I had was, is there anything in terms of the climate change that's happening on our planet at the moment that might alter the way in which you live positively? Like maybe,
I think
anything?
Yes, it's something that I'd like to say to everybody in terms of sustainable. I mean, I think you can look at the extreme events, but I think there are ways that we can deal with some of these problems that we haven't thought about as seriously as we should be thinking about them. And that is looking at more sustainable ways to manage our environment and looking at nature-based solutions to some of these problems. And one of the technologies that's developed in the United Kingdom and other places in Europe is natural flood management, using the landscape itself and its curvature, etc., to slow down flows. And this has been shown to be quite effective in smaller catchments, that where villages are getting wiped out. And it is a matter of scale. You're not going to stop the catastrophic flood from happening, but you're going to stop these so-called nuisance floods. Now, nuisance floods are ones that happen far more often, and if you add them all up, they occur more frequently. And then you've got your big flood. The cost is more of the nuisance floods than it is of the big flood over a 10-year period. So we should be addressing this with more nature-based and sustainable measures, in my opinion.
Thank you very much, Mary, and thank you very much for everyone for joining us. We'll give you a round of applause.
Thank you.
With Luke O'Neill, and we'll be looking at everything from antibiotics to infectious diseases. Thank you very much. Cheers.